In this video, we're going to look at the concept of plotting data points and making graphs. So first of all, let's talk about what it means to work with two variables and how we can use that information to help us plot data points. When you have data in the form a, b, then the first coordinate corresponds to the independent variable, and what it does is it tells you how many units to move along the horizontal axis on your graph. The second coordinate corresponds to the dependent variable, and it tells you how many units to move along the vertical axis. So in this case, when we have the point a, b, we know we have to move a units along the horizontal axis and b units along the vertical axis. If a is positive, we move to the right. If a is negative, we move to the left. For b, if it's positive, we move upwards, and if it's negative, we move downward. So let's get a bit of practice at this. Here we're given 4 points that we're asked to plot. To help us out a little bit, let's just label the fact that each grid line is just going to correspond to 1 unit, just so it's clear what we're doing. And so now let's go ahead and plot each of these in turn. So first of all, point A is 2, 1. That means we move 2 units along the horizontal axis, and because it's positive 2, we move to the right. So we're going to move 2 units to the right and 1 unit upwards. So here we've got point A. Let's move on to point B. So we've got the point 4, -3. So we're moving 4 units along the horizontal axis. Because it's positive 4, we're moving 4 units to the right. So let's move 4 units to the right. And now the -3 is along the vertical axis. Because it's negative, that means we move 3 units down. So again, we moved 4 units to the right and 3 units down. So we've got the point B. As for C, it's -3, +2. So we move 3 units in the negative horizontal direction and 2 units in the positive vertical direction. So that's 3 units to the left and 2 units upwards. So we've got point C. Finally, point D is -2, -3. So we're going to move 2 units in the negative horizontal direction, so that's to the left, and 3 units in the negative vertical direction, so that's downwards. So again, we move 2 units to the left and then 3 units downwards, and we end up at point D. Again, to plot data points, all you need to do is move the indicated number of units to the left or right, and that's given by the first coordinate in your point, so that denotes movement in the horizontal direction. Again, positive is to the right, negative is to the left. The second coordinate of your point gives you the amount of units to move in the vertical direction. So positive means you move upwards, and negative denotes that you move downwards. So aren't we done yet? We just learned how to plot points, and that means basically we can plot all our data. So isn't that what we need to know in order to be able to do a graph? Well, not quite. There's still a few other things. Think about it. If someone gave you a piece of graph paper with some data points and said, "So what do you think?" Well, you wouldn't even know what the data represents. You wouldn't be able to understand the scale of it. You really couldn't get any information from it. So similarly, when you're handing in a graph to someone to read, well, you need to make sure that it's very clear what all of the information represents and denotes so that the graph is meaningful to the reader. So first of all, it's important to give the graph a clear title, which indicates what's actually being displayed. Next, you need to label the axes, and that includes several things. You need to give titles to both the horizontal and the vertical axis that are clear and show what the variable is that's being used. You should indicate the name of the variable, so you should probably indicate y versus x or t, so whatever the actual variable is that you're using, because if you then have other things in your paper, like formulas, for example, that relate back to the graph or some sort of calculations, it's important to know which variable you're referring to in those formulas. As we did on the previous slide, you should put some numbers on the axes so it's clear whether each little unit of the graph paper is actually 1 unit or 5 units, or you mean it to be 10 units. So having a scale is very important. And lastly, you should include units. So are you measuring lengths in meters or centimeters or kilometers, for instance? All of this information is vital in order for someone to understand your graph. So finally, let's put all of this together and actually do a sample graph. So here we're given data from an experiment measuring water temperature as a function of time. So let's go ahead and plot the data points and label the graph. First, let's start with our title. So here we've given the title Water Temperature versus Time in experiment number 1. So a couple of things here. First of all, time is the independent variable and water temperature is what's depending on time. So water temperature is our dependent variable. So we write water temperature versus time. And I've added the in experiment number 1 because let's say this was from your biology class, your physics or chemistry class. You might be doing several experiments. When you hand in a lab report, if this is the only one that you did, then it's probably pretty clear. This example is a little bit vague because we just said water temperature versus time. Well, water temperature versus time in what experiment? Normally, you'd have much more detail that you could write in a title, but here, assuming that it's some lab you're doing, it's probably all right to specify in experiment number 1 or number 2 or number 3 and so on, so that it's clear which experiment this graph corresponds to. You should of course check with your lab TA and or professor regarding whether or not they want more detail in the title, and have a look at your lab manual and the type of instructions you've been given as to how to create graphs to see if this is what is expected of you. Again, the more information you can give in the title, the better. Water temperature versus time typically is still pretty vague. Normally it would be water temperature versus time during such and such an experiment. So again, the more detail you can provide, the better, but here no other information was given in the question, so we'll just specify water temperature versus time in experiment number 1. Next, let's go ahead and label our horizontal axis. So again, this corresponds to our independent variable, which is time, and we specify that we're measuring it in minutes. And for the vertical axis, this corresponds to water temperature, and again, this is being measured in degrees Celsius. So note that we've included both the titles and the units, both of which are very important. And as far as what we are going to call the variable, you might call time T, for example, and let's say water temperature we'll call capital T. So little t is time and capital T is water temperature. Now we need to find a suitable scale before we go ahead and plot the points. The values that we've got for time are 0, 5, 10, 15, 20. So let's say that every tick mark represents 5 minutes. So then what we've got is, let's just label every second one. Each one represents 5, so the tick marks I've chosen to label, and I haven't labeled all of them because I don't want the graph to be too messy. You can label more of them if you like, but this is enough to show that since 2 tick marks correspond to 10 minutes, each one is 5 minutes. Be careful when choosing the scale. You want the graph that you're doing to take up as much of the graph paper as possible, so you don't want to choose a scale where 1 tick mark represents 100 minutes, for instance, because the entire graph will then be crammed into a tiny little corner and it'll be very difficult to actually read anything. Again, choose a scale that seems right. Here, we could have, since we're not going to the right of 20 minutes, for instance, chosen 3 tick marks to represent 10 minutes. But then it might be a little bit harder to figure out, well, what's 5 exactly, what's 15, where exactly is the halfway point. So there are different ways of doing it. As for the temperature, again, there's different ways that we can do this. We are going all the way up to basically 50 degrees, so we could have each tick mark represent 10 degrees, for instance. So what we have then, and let's just label all of these because there seems to be enough space to do that. Another option is, here temperature starts at 20 degrees, so the graph isn't so bad, but if it was starting at 40 degrees, for instance, and we didn't want to have the entire bottom part of the graph to be empty, what you can do is this symbol, I'll just draw it in and then erase it, that shows that there's a break in the graph, and then you can start your graph at a more suitable spot. Since our graph is starting at 20, then this is okay, and we can just leave it as is. Again, if you're unsure, you can ask your lab TA and or your professor and have a look at the lab manuals and instructions you're provided with to see what's expected of you. So now that we've done all of the work in labeling our graph, let's go ahead and plot the points. Our first point is at 0, 20. So when time is 0, we've got a value of 20. Next, at a time of 5, we've got a temperature at 25. So we can go ahead and fill in our next point. At a time of 10 minutes, we've got a temperature of 27. So you're going to have to guess exactly where 27 is. It's not perfect because the graph doesn't have any other smaller tick marks to help us out, but we know it's going to be somewhere between 25 and 30, closer to 25. Next, at 15 minutes, the temperature is 35, so we can go ahead and plot our next point. And finally, at time equals 20, the temperature is 48, so we can go ahead and plot that. It's tricky to figure out exactly where 48 is going to be, but we know it's going to be between the halfway point at 45 and 50, closer to 50. So we do our best to draw that. And now we're done. Do not connect the dots at all on the graph. That's a common student mistake. Remember that this represents real data, so we can't just connect the dots because then it implies we have data at 18 minutes and 18.3 minutes, which we don't. So we should just present the data as we've got it and don't do anything to actually connect the dots unless you're specifically told to do some sort of curve fitting exercise, in which case you might try to figure out the best line that goes through the points or so on. But again, that's only if you're specifically told to do so. Otherwise, you just present the data points on the graph as is, and you're done.